Assalamu alaikum, welcome back to my channel. I received one villa to make electrical drawing, meaning I have to calculate electrical load. So I thought to share with you so you can also learn how to calculate this villa. And this is the villa I have received. You can see this one. I think this is the ground floor. Furniture, yes, ground floor. And actually, it's a furniture layout. This is first floor, and I have a penthouse. And also I have, yes, uh, I think this one like Majlis. Yeah, this is a Majlis. So what I did, I import this one to the cat. Okay, I import this one to the cat. So I place some sockets. So some area I place first. So like this. So here, let's say the person sitting here. So if you want to use uh, power outlet, so you don't want to reach up to here or here and take the cable up to here. Let's say he's charging mobile while you want to use or laptop something. So I add some floor box near to the sofas and TV. I add two wind socket. So this one should be another 200. Okay, Control C, copy. So I have add two twin socket because here we have TV, something like that. You can design your own. So here, if you see, I have pantry, so microwave. I put dishwasher and this one also uh, coffee machine. So microwave, if you check for dishwasher, I put 2000 kilowatt, meaning 2 kilowatts, and 1.2 for the washing machine and 1.2 for the micro coffee machine. So if you don't know with this load, you can go with the general load with here. So type here. Let's see microwave load in kV. So you will have something 8 kilowatts, 0.8 kilowatts. So I put 1.2. So because in Qatar we have 1.2 kilowatts, 1.2 kilowatts coffee machine also. So it will better you put little extra too. It will be help you to calculate. Uh, if you have go higher, it's always better. So you will not have any problem. So like that, I have too much outlets like that. So some floor box in the sitting areas and here sitting area. So this floor box I consider one twin socket, meaning each twin socket 100 watts, single socket. So double meaning 200 watts. So here I put, I already told you how I put it here. So something like that, I update everything. And here, this is a cooker. I put 2 kilowatts for the cooker. And also in the same time, um, I put microwave and coffee machine, same load what I follow there. The cooker, I put 2 kilowatts, so this one I don't need it. I put extra, so DP switch for the cooker. And this is 100 watts for the shower socket. I put it because here wash basin here I put. So maybe they will not need, no need here because as per the interior designing, maybe they don't need. But when you are designing, you put. When they're removing, no issue. But when you, without adding this one, when you calculate, let's say, the sum of amount of 10 or 15 kilowatts come, and later if they add, it will be problem. Removing, no problem. So just add. So here I add something like that. So I see here lift. So I need a isolator. So it will be one isolator. So there's a two type of lift. The motor will be top and the below. So we don't know where it will come. And so here I just want to calculate the load. So I put the load. So I copy this one. So here I put 2 kilowatts. So let's check in the Google lift. Uh, so we don't need 13 passengers, maybe 5 passengers, 5 passenger load. Sorry, passenger. So actually we have to take this one 4 to 6%. It will be a very long video, so I want to teach you everything how I am calculating. So it's we have to search for that one. So let's type villa lift KW. Good. So its power setting is almost 1.12 kilowatts. So I will go with the 2 kilowatts. Something like that you have to search. Okay. So I add same thing here and everything I calculate just wherever I want. It depends. So in the bedroom I put two to it. Maybe they will in the ID one single and one single enough, but put two. As I told you, removing not an issue. So I'll add like that something to enter ground and fest and penthouse and majlis. So I took the total load here. So I have a lift. If you see this one 16.9, I have a lift uploaded. So if I type S2, select all S2, enter. Sorry, I have copied one of this one. S2, enter and click here. It will give the load. So before I already calculated, so that's why it's coming same 16.9 kilowatts. If you want the lifts, you can download from my other video. There is one video I have already uploaded. Auto sum uh, number, how to calculate total. There's one video and I have provided link. You can take it from there. So here I have 16.9, 8, and 11.8 and 7.4. So I have provided for the lift. So I have downloaded one single line diagram. It's also I have in my other video um, how to make single line diagram. So same you can copy this one I need. Okay. Same I have provided in my one of video. You check in the step by step electrical. It's there. Okay. So I copy this. Okay, this one I don't need it, and I don't need this one. So here, and I will copy this one also. So let's make this one smaller. Okay. So I have this one 16.9. So I will dedicate this one DB GF with that. So I will remove this one. I don't need it. This one also for now I don't need it. So if you don't know how to create, just pause this area and you can understand. Okay. So DBGF villa. So let's remove the 0. I have 16.9 load. So connected load is 16 point. Okay, that's already fine. 9 kilowatts. Okay, demanded load, I didn't calculate it. So let's make it. This one, voltage drop, I don't want to calculate now. This will be later. Okay, well, let's keep it here. This one, because it's a proposal, I have to just want to share my work. It's a proposal, so this one for now, no need. For now, we need this connected load. So this cable we will calculate later. Then the second and G1F or GBFF, we can go like that. GBFF. So I have how much? 8 kilowatts. So I can go with 8. Then I have GB penthouse 11.8. So we can go with a pH 11.8. Okay. And then Majlis. So we can go to Majlis. We'll go MG. Okay. How much we have? 7.4. 7.4 kilowatts. Okay. So this one only for the power. So light, we have to add for the light. So I will just copy this one. Okay. Okay. Actually, I want that. CP. This is like a thumb rule calculation, not actual. So let's calculate the light. Okay, this room, maybe we can use pantry light, 2 numbers. And here we can use 2 drop light, like a pendant light, so 4 number. And we can use some small spotlight, 1, 2, 3 here, 1, 2, 3 here, so 6. And here we can use sync light, only just small light 4 and 4. Okay, so this is well, so they need some luxury type. So we can go like that. So 8 by 2, 10 to 12, and here for 16. So 16 light, and I will consider each light 50 watts. So here, we go with the LED type. So 16 meaning around 800 watts. So let's put here 800 watts. Where we can go for the legs, because the spotlight maybe 25 something will come. So let's consider, okay, for now we consider 800 watts, 16 light. Okay, so here we can, this is TV room, we can put 1, 2, 3, 4. 1, 2, 3, 4. So it will be too much. Maybe we can use 4 by 3. So 8, 12. 12 meaning 600 volts. Okay, so we can go with 600. We can go more. We can go 1, 2, 3, 4. Let's calculate the length, DLI. So how much we have length? So it's sorry, this is not scale. So it's almost 7 meter, meaning if we are using a big light, we need 2. Okay, in each 3 meter one light we need. So here will be 3, 1.5, 1.5. So one, again another one, another one. So we need around 3 light here, another 3 light here. So 6 light. So we can consider 300. So if we are using a small type luxury light, so we can go for the 600. So it's enough. It's a thumb rule calculation. So here we can go for the 200 or 100 is enough. We can go for the 2 light. If we are using step light, it will be more. Already we are going with more. Let's put here 100 here, and we can go with 2 to 6, and here we can go 4, 10, 1, 2, 3, 13, 13 minutes. We can go for the 14, 700 light, 14 minutes. So you think this one 800. So 2, because I put 2 drop light here. So we can go with like that also, 2, 2 and 4. So another 200. We can go for the 900 here. Okay. Here we can go for the 2. 900 is enough. So let's copy this one. We can go with this 100. Can go for the 200 because post vision we may use mirror light. And here we have mirror light, toilet light. Mm, so here I think we will go with 100. Okay. And this area you can go to in 510. So 1 kilowatts. And here 1, 2, 3, 4. So we can go with the 200. So if it will be included with the load, so we don't have to take the lift one. Here we will go with the 4, 200, 200. Here we can go 200. Here we can go 400. Okay. So here I'll go for the 3 kilowatts for the chandelier. I need to put the uh, chandelier, OE chandelier 1.5 kilowatts. And also I want to use some spots. So 1, 2, let's say 7, and in 3 minutes 6. We can go for the 6. How are you calculate? 7 meaning each 3 meter we need normal one light. So 7 meter meaning let's draw a circle. E 3 meter. So here I have to put 3 of theta. T Li. But this one not properly scaled. So this is 3 meaning 7 into 3, that meaning 1.5, right? C E D 1.5. Okay, around like this. So 1, 2, almost 3. Okay, so 3, 3 is 6, 7, 8. So around another 400. And yes, 400 I need. Let's go with 500. 3, 3, 6, 8. We will go 500. As I told you, we can increase, not decrease. So I will follow same here also. So I want one chandelier here, one chandelier here. Okay, so 2 chandeliers, 3 kilowatts. So I will go with the 3, 3, 3, 4, 5, 3, 3, 6, 8, 400. We can go 4, 8, 10. So 500. So I need to add another 500. This is approximate, it's not actual. While we are design making the actuals of drawing, the load can be increased or decreased, but for now I am going with the higher weight. So actually the chain gear cannot be 1.5 kilometers sometimes, can be less because we have some special designs also. So as I told you, this is a normal regular calculation. So here we can go 1, 2, 3, 1, 2, 3, 4, 5, 5 I mean 10 lights. So we can go with 500 watts. Okay. So let's copy this one. I think almost I cover everything. I didn't go for the external light. Let's put external light around. Consider 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So let's go with 1 kilowatts. Better. So copy. Okay. So I will copy another one. So let's select S2. Let's select S2, enter. So it's 17.6. So if I come here, okay, let's move this one up. Let's move this one. 17 point something I put it. How much I put? 17.6. Actually, I have to calculate this one. Let's go calculator. Okay. 17.6 plus 16.9. So around 34.5. So let's bring it back. 54.5. Okay. So same way, we have to calculate the rest here also. So I will post a video. So because you don't need to see everything. So it's the same concept. Then I will continue. So I completed. I reduce here from 2 kilowatts because lift I cannot put it in the TV. It should be separate. So I will put one isolator. So I will copy same this one. Case not. So here, let's make bigger. Can put it the 3 piece. So I copy same. So we will put lift. Okay. Go with 2.5. Let's go with little extra. 0.5 kilowatts. Okay. So as a thumb rule, if you divide 2.5 into by 440 or 420, we can go with the 440. 2500 divided by 440. It's around 6 ampere. So we can go with 20 ampere. So let's go with 20 ampere. 20 plus TPA. It's a small lift, so no need too much power. So we can go with ampere. So as I Google it, it's almost 1.12 kilowatts. It's just showing a single piece. So it's better 20 and 30 pane is enough. Oh, so it can be increased or decreased. So for now, it's okay. Okay, we have some water heater, centralized water heater. So I copy scene. Because this villa, we need water heater. So I have two nodes. So WH, dash 01, CWH we can put. So centralized water heater. It's around 4.5 kilowatts. So if you Google it, you can know it. Centralized. Or you can go with the water heater system. So 0 kilowatts. So it can be maximum 4.5. So I will go this. I'll go with the maximum. Okay. Choose number 2. Okay. So I think I cover everything. So 4.5 kilowatts, also 2.5 ampere is enough. Actually, uh, actually it's double. 1.75 we have to calculate. Yes, meaning 5 into 1.54. It's around 7.7. This is why 1.54. So normally kilowatts, let's consider 1 divided by 3 root, okay, into 1000 into power factor 0.9 equals so 519.6. And actually it's not 1, it should be 1000 divided by 3 root, okay, and into 440, I was wrong, into zero point 0.9. So it's coming from, it's only, let's go with the Google, no, Excel. So you have 1 kilowatts, okay, it should be divided by root 3. I will take root 3. So I don't know how to type root 3, so I will go with this one. Copy. So divided by this one in the bracket. Control V. Into 440 into power factor 0.9. I will go. Just close bracket. Close bracket. And here will be equal. I think I press something. Equal. enter 1.45. So if you go for factor 8, it will be 1.64. It's like that. So it should be, I'll go with the 9. So it's 1.45. So I have, let's say, 4.5 kilowatts into 1.46. So 20 ampere enough. So this is how we calculate amperes. Actually 420 normally we go. So it will go 1.52. Here we can go with 8. So it's depend how you take. So it's 1.71. So it's depend for a 415 something will come. So that's why I took I don't know, it will become 415 the same amount. 73 and this one 9. Yeah, 1.54. So it is 415.95. That's how I calculated. I forgot. Normally they calculating method in Qatar. So it's done. So it's enough 20 ampere. Chill water, sorry, centralized water heater, two numbers, one wave. And I have calculated for the light and for the power. So for now, we don't need this one. I can explain you this one next video. This will take too much time. Let's finish the video. Now I have to put some load AC. So they send me this drawing. So they have selected some unit and they check with the material submetal meaning supplier. And they have given this is designed by AC people. So this one we cannot do. So the AC people have to do. So they selected these machines. So this is a machine type and this is the quantity and this is the kilowatts. Sorry, ton. That's power. This is the power. This is what we need. So it's all three phase. So this is what we need. Okay. So 5.47 by 17 nos. Okay. So how much it will come? 5.47 by 17 nos. So it's almost 92 kilowatts, 92.9. So here we have like 2.9. Okay. Three phase. Air capacity, net capacity. Okay, this is the calculation. So 5 kilowatts, they have 8. That meaning 40. And 3.79, they have 4 number. 3.79. Meaning 15.6. Okay, 0.6. And they have 2.25, two numbers. Meaning 4.5. So this one is a very big one. If I add this one by one, it will take a big space. So let's put one MCC panel better. So let's remove, let's keep it. So I will copy this one. So I will put MCC AC dash. We will put MCC panel. So what is the benefit MCC? In case of you can control with the specialized BMS and some other home automation systems. If you are using, you can control it. So let's see how many votes we have total. So 17, it's a big MCC will come, no problem. So let's go here. We can put this two, this two. Okay, here it will load. It's not loaded. So select S2 60. So we can put 1 and below. So 92.9 is 1. And we will put another MCC. So let's get this one. Let's make this one little smaller. Pressing enter. So, another one. That one how much? 60.1. So I go with 60. Okay. So we have spare 1, 2, 3, 4, 5. I think too much. Let's calculate 1, 2, 3, 4, 5, 6, 7, 8. Did I hear you? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is enough 12. So this one. Okay, this one I will arrange it. Okay. Now we have to, let's keep it same. And this one we have to design. We have to take care of this cable. Okay. Let's go one by one. So I have 32.5. So as I calculate here, 1.54. So we will go with 1.54 better. 32.5. So 32.5 means 1.54 almost. How much? 32.5. 32.5 into 1.54. So 650. So I will go with this one, 80. So it's already 80. Okay, this one we can go, it's little lesser, so we will go with this one, 60. No need extra. We'll so go with 60. This one we will keep 80. This one I will go with 40. Okay, we'll go with the 40. And this one also will go with 40. This is 92, we need almost 150. Let's calculate 92.1. 92.1 into 1.5. So it's 141. We will go with 160. So 160. Yes. Copy. Copy. So all three paste. So we will put 100 spare. 180, 63. 140. Okay, it's enough. Okay, okay. So let's calculate total load. Two enters. Okay, Y. So there's CL find. Okay, CL. Okay, let's go CL please. Okay, now let's go with the double dot. Replace. Okay, now let's go with the KW. Replace it. Okay, now let's calculate. Let's do that. So 260 kilowatts. Let's go with 260. 1.5. So 400. So here 630 it's enough. 400. We can go with the 500. But 630 is okay. Okay, this is how many way we have 12 way. Okay. So demanded load. So we have to put the demanded load. So demanded load, you can go with the diversity factor as per the Karhama regulation. Diversity factor electrical. It can be changed country to country. So these are the factors, diversity factors. So here you have to take from the Kaharma book in Qatar. So for now, as a thumb rule, I am going for the 50%. Okay. So 50% of 32.5 can 16.25. So cannot go 16.25 because I have connected some cooker everything. So actually what will happen? I have to calculate this one first. 2, 3, 4, 4.4, anything else? 6 point, yeah, this one also half. Actually, I have to go to the Kahama book. Better. Kahama regulation. So electricity, okay, it's downloading. Control F, diversity. So I have how many change? 15. Yes. 60%, cooker 40%, water heater 30%, other. So let's copy this one. Can screenshot Windows Mod Shift S. Okay. So let's put it here. So general 60 and this is 40. So general load meaning light and socket. So if I minus light and sockets, here I have 4.4. Here I have also 4.4. So 8.8. If I minus 8.8 meaning 40%. 8.8, 40%, how much? 8.8, 2.4, 3.52. Okay. And how much? 3.5. Let's type it here. 3.52. 3.52. Then how much I have balance? 8.8. 32.5. 32.5 minus 8.8. So 23.7. How many percentage? 60. So into 0.6, saying 14.22. So how much to come? It's 17.74. So almost near. So what I am going to do, I will go with half everything because it is a proposal only. So when we are doing actual, we have to go everything like this. What I did now. So here I will go 18 meaning 9.10. Okay. This one I will go with 9.4. And I will go for the 13.4. So lift, they are mentioned nothing lift. Motor 50%, okay. So we can go for 1.25. So heater, cooker, water heater 30%. 30% meaning 4.5 into 4.5 into 0.3, 1.35. Okay. Go with the same. So this one I have to go 90%. So how much? 92.1 into 0.9, 82.89. Okay. Another one, 60.1. Point nine. So 454.09. 409. Okay. Now let's select this all. Find and replace CL to BL. Demanded load. Okay, done. Now copy paste. Did I mention here total connected load? So this is the connected load. S2 260 kilowatts So it will be here 260. So maximum demanded load, I have to do same, find DL, empty, replace, okay, this one, replace, okay, and KW, replace, okay, done. So let's copy this. Actually, I missed something. I will edit class 190, 570. And let's get another 0. Okay, maximum demanded load test finished. So it's already done. So I calculate all the ampere as per connected load. Okay. So here 32. So here I went with 80 ampere. So let's go for the car one. So now capacity, not this one, not this one. Okay. This one, single core, no single core, 3 core. I need this one. So 80 ampere. Where is the 80 ampere? Voltage drop per ampere. Current rating for label 8. So here 87. I go with the 35 because I use 80 ampere rating. So this is the line. Cable running underground or above. So 87, 82 is for core 35. Okay. So here for the 60, we can go 25 or 16. We can go both one of these. Okay. 16. So this one we can go with the 16, 16, and this one we will go with the 35. So it's not we can calculate, we can put cable like that also because we always go with the extra here. But if you you see 32.5, right? 32.5 to 1.54. So it's 50 ampere. So if you go to this one, the 50 ampere, this one. Okay, so 10 is enough. But in case of voltage drop everything, we go with the 65. So this is actual. Let's say they add the spare anything and blah blah blah, then it will go 73. So 4 core 25. So we don't know how this is actual load. If they add additional, so this cannot handle. So should be more. If the distance is far, so they will go to the next 65. Then additional load, we have to go to 73. And we don't know what kind of load they will eat. So 4 core 25 enough. Almost enough. But we can go for the extra. So maximum protection, because as per kata, they always go for the maximum protection. So it's your decision how you want to do. So it's as per the country budget. So I will go with maximum. For core 35, this is distance, I don't know. Because I will not calculate now this one because the proportion load. Okay. So here I'll go with the 16. So 16, same size. We can go with 16. Yes, everything also 16. 10 inch to 10. 16, 16, 35, 16. So here I will go with 16. Here I will go with 35. because the load and also the main breaker. So 14 can be done with the 16 also because it's a lift. I will go with this one. This cable can be changed as per their requirement. Okay, this one also 16 can be done. Actually 10 can be done. So around 10 ampere, 10 ampere. Yes, you don't have to go more. 10 is also more. Can go with the lower. Like this is around. This is not will enough. Around 10 we can go. Okay, because this is 3 base. Yes, 10 is enough, I think. This also as per the experience. So we will go with this one 10. Also we will go with the 10. So sometime you have to go with your experience. Sometimes you have to go with your knowledge books. Okay, uh, it's depend. So I will go with the 10 because this is 40 and this 40. See, this is 40 range. So I will go with the 10. But the actual load, it's like 10 ampere loads. This, if you see this one, even 1.5 is enough, can handle 14. But if you go the distance, it will be go for the 20. So can be lower, higher voltage possibility. So this can be done. But anyhow, here mostly we used like a centralized water heater or a lift kind of things. 4 core 10 or 4 core 6 something. So I will go with the extra. So this one can be changed as per the requirement of the supplier. So the big problem is this one, 160 amperes. So 160 around here. So I will go with 120. Okay. So 120. Okay, 120. And earthing, the next below size, you can go next below size, 95. No, the actually half size. 120 meaning you can go with the 70. So 150 you can go with the 95. Something like that. So actually 35 is 16. 50 is 25. 70 is 35. 95 is 50. 70 is 35. 95 is 50. 120 means 70. 150. Like that it will go. So 70. I think this 70 is enough. Okay. Then this one. See, this one is not 100%. This is just to take an idea to how to calculate, how to design this one for the proposal only. When it's come to the actual, you have to take care of many things. So this one for the proposal only. So don't follow 100% this. So this one will help you how to think and how to calculate some, calculate your design. So here 160. Still, I don't need 160 here. So how much is on 160? 160 is 120 ampere almost. So yeah, we will keep this one same. Okay. So cable done, demanded load done, and everything done. So I forget some pumps, uh, lifting pumps, pressurizers pumps. So lifting pump and there will be a circulation pumps and there will be a what there will be another pump. What is called lifting pump, circulation pump, sump pump, pressurization pump. So when you open the water tap, the water will come very fast. That one called pressurized pump. So those things I have to put three pumps lifting. So that can be included here. So it's a small uh, load. So no need to add extra. So let's keep it. We can use it in the sprayer also. So what else I have to uh, so this is 630 ampere and CCB for 15. Okay, this is enough. This is how we calculate SLD. So based on this, they will apply for a requirement how much they need. So this is the load as per this. So additional load can be covered because I already had some additional. So if you understand this one, this is a thumb rule selection. So I didn't go for 630. How much we need? So it's 4 630. How much? Tura? Actually, they will not provide like this in the Karama. So they have to take two connections. But for proposal, I will give like this. This is their job. Okay. So let's go for the 240 meaning this one can be covered this. So 2 run is too much. Actually, I have 630 ampere. 630. Okay. By 2 this one. I go 240 meaning 250 ampere. So 630. So I will have to decide. 190 meaning around 500 ampere. If I go with the demanded load, so it's okay. So let's send this one to the guy and let's wait for the reply. So don't think always you're right. You maybe sometime miss something. So until next video, we will meet. If you not subscribe my channel, subscribe so we can learn together. This is type of uh, thumb rule load calculation. Okay, only thumb rule. This is not 100%, just for the idea. So once everything approved, when you go with the series design, so this everything will be changed. For example, this load can be changed, and this load can be changed, and this cable, as for the distance, can be changed because of the voltage of blah 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 thing. This one can be by 2 SMDB or 3 SMDB. It's depend. Okay. So for now, this is we are just giving this much load will come, and if we are including one, it will be like this. So the government will tell them, no, no, we cannot provide 630 ampere one time in each run, meaning one run. We will provide two connection or three connection. This depend because in our country only they will provide little, actually 32 ampere only. So in that we have to decide everything. We don't put too much light. We put in my room only one light, 50 watts. But here you see 10, 15 lights in Qatar. They have too much money and they are spending as they have. And also, I think here current electricity level now, not too much money. The person who earn too much money, they are spending. Okay, until next video, we will take care. Until next video, take care. Bye. Assalamu alaikum.